Hi, welcome to the another class of transmission systems. In this class, we will study here about the various transmission media, the various transmission modes which are used here in our telecommunication systems. Transmission basically refers to that we have to transmit the signal from one point to another, or we can say that from one device to another. Transmission is basically the technology which is implemented to convey the information here from one end to another end. Now, this transmission here can take different medias here. That means either it can be transmitted through your wired media or it can be transmitted with your wireless media. That means the information is then transmitted here in some kind of energy, like your electrical energy if it is going through your wired medium, or your electromagnetic energy. That means if it's going through your air transmission media. So basically, if we have piece of information here, like it could be your voice, your data, and it could be images. Like I have analog transmission and digital transmission. So we have your digital transmission techniques, like I have my voice. This is my analog, because in analog signal we have the intensity of the signal changing at every interval of time. I have to transmit my data through my digital transmission techniques, digital media. Then I have to convert it into some digital format. So I have converted this analog into digital, having some discrete values, but still then my like 0 1. Either it is taking the wired media or the wireless media, it's not being transmitted here like a 0 and 1. So this is being like your electrical signal or going as form of electromagnetic energy here. Similarly is the case with you like images also. We have to convert into this format, and then they can take either the wired media or the wireless media. So in our telecommunication system, we're using here both the wired and the wireless media here. So we will be studying here about the various transmission medias and the various transmission technologies here. Now, if I talk about the electromagnetic energy here, so electromagnetic energy basically is the combination of electrical and magnetic field which is vibrating in the air, and it is containing like your voice, power, radio waves, etc. So these voice band frequencies are also transmitted over the cables, and they also travel through your RF waves. So that means we have different medias here to transmit our data. Now in our cellular technologies, like we have the cell phone technologies, we're using the wireless mean. That means to convey the information between the mobile station and the BTS, we're using the wireless media. But somehow for our backhaul networks, we're using like our fiber optics technologies, our SONET and SDL technologies here. So the transmission media here can be categorized into two subparts. So it refers here to the wired and the wireless media. So this can be also written as guided medium and unguided medium over here. So first of all, we will go through this wired and guided media, and then we'll study about the wireless or your unguided media here. So I have guided media here. So guided media means that it provides a physical conduit. That means the signal which will be traveling through a guided media, it will be directed and contained in the physical limits of that particular conduit. That means if we have to transmit our data from one device to another, or like from one handset to another, so we will be using that conduit, that physical medium. So these particular physical mediums or the signal which will be traveling through this guided media is contained in the physical limits of that particular conduit. So it includes here, like here, twisted pair of cables. After that, we have coaxial cables, and then the fiber optic cable. Three types: twisted pair cable, coaxial cable, fiber optics cable. Now, in twisted pair of cables and the coaxial cables basically uses copper as a media to transmit the electrical energy, because it accepts and transmits the signal in the form of electrical current. And after that, we have fiber optics cable. Now, fiber optic cables basically uses glass or fiber, so that can accept the light signals and transmit them in the form of light energy here. So first of all, we have here the twisted pair of cables. So the twisted pair of cable is also categorized as STP and UTP. UTP is your unshielded twisted pair of cable and STP is your shielded twisted pair of cable. So if I have here UTP, which is your unshielded twisted pair of cable, so this is basically two conductors, or these are basically two conductors which are surrounded by some insulating material here. So that means I will have such kind of material here, which is then surrounded by some insulating material. I will have some insulating material over it. So these UTPs, these twisted pair of cables, are the most commonly used in the telephone systems, and these can transmit your data and voice because the ranges from your 100 hertz to 5 megahertz. This is the bandwidth which is supported by them. So the most common use of such kind of cables here is with the telephone systems here, which can transmit the data and the voice. So it consists here the pair of conductors which are basically your copper. So each with its own colored plastic insulation. It will have different colors plastic insulation. So which will be used here to identify that which specific conductors in a cable belongs or are in your pair. So we have like solid copper conductors like this, and then the insulating around it, which is basically your outer insulator here. So after your twisted, we have different categories here for twisted pair of cables also, like category 1, category 2, 3, 4. So then they will have different data rates. Like if you have category 1, so it is only it supports only the transmission of your voice. After that, you have category 2, so it can transmit the data up to 4 mbps. Then your category 3, it can, so it will have more number of twists. It will have 3 twists per foot and it can transmit up to 10 mbps. After that, category 4 can transmit your 16, and category 5 can transmit up to your 100 Mbps. So these are basically less costly, easy to use, cheap, flexible, and easy installation. So basic application is like in your local area networks or your Ethernet. So these pairs then have the connectors which will be used here to plug into the device. So the connectors which are supported here for these kind of twisted pair of cables are like your RJ45 connectors. Now after that we have twisted pair of cables. Shielded twisted pair of cables. So it has a metal foil. That means it will have some extra insulation. It will have an end case which will have your conventional twisted pair of cable. So that metal casing will prevent from the penetration of electromagnetic noise. This is here shielded, so it can eliminate the crosstalk up to some extent here. So that means it will have a plastic cover, then a metal shield, and then the insulation over the copper conductors. This will be your copper conductor, this will be your metal shield, and this will be your plastic shield. So this is basically extra encasing so that the crosstalk can be reduced here. Now after a twisted pair of cables, we have coaxial cable. The second category under this is your coaxial cable here. So coaxial cable carries signals of high frequency from 100 kilohertz to 500 kilohertz. It can carry higher frequency signals here. So the construction of this coaxial cable is different from your twisted pair of cable. So this coaxial cable doesn't contain twisted pair, but it has a central core conductor of solid copper, which is then insulated, or we can say enclosed in an insulating sheath, and then it also protected with some uh, plastic wrapping here. So you will have this plastic final wrapping. After that you have insulators here. Like this is your outer conductor, and then through the central coax you will have this inner conductor, which is the main conductor. This is your outer conductor, and these two are your insulators. So these are a better provision for transmission as compared to your twisted pair of cables, because these can carry signals of high frequencies and these have more insulation. So that means it will have less crosstalk and interference as compared to your twisted pair of cables there. So your coaxial cable also have different categories. That means different categories supporting their different data rates there. Like we have different standards like RJ8, RJ9. So they have different applications like your Ethernet or for like your TV transmissions here. Now after your coaxial cable, the third one is your optical fiber. Optical fiber here. So So, optical fiber. Fiber basically here is made up of glass or plastic and transmits the signal in the form of light. That means the form of energy is light and which travels at a very faster rate as compared to the other medias like your electrical conductors. So, optical fiber uses glass and plastic material to transmit the light. That means information here will be like transmitted here as your on and off flashes here. So, now, light has certain properties like your refraction and your reflection. So, optical fiber uses these properties. So, basically, optical fiber here uses the reflection property of the light to guide it through a channel. So, basically, if you have a material, so it will be here uh, surrounded by a cladding. So, we will have two different materials which will have different densities here. For example, if you have glass and plastic or core, that will be surrounded by a cladding of less dense material. So if this is your core, then the cladding material here will be more dense. We can make it more, if this is more, so this can be your less dense here. So what happens when the light travels into more denser medium? So the angle of incidence is greater than the angle of diffraction here. And when it penetrates into less dense medium, so the angle of incidence will be less than the angle of refraction here. So fiber optic technology takes the advantage of these to control the propagation of light through the core and cladding. That's why we'll have two these materials having different densities. One will be less dense and one will be more dense. So when there is a change in the incident angle, so it results in the refracted angle of 90 degrees. So that means the refracted beam here lying along a horizontal line. For example, if this is my medium here and if it is traveling here into more dense medium like this. So this angle of incidence here will be more as compared to the angle of refraction here. And if the phenomena is opposite, so what will happen if it is traveling through this medium, like from more to less? So it will become here more, and the refraction here will become large. So when this change in this angle of incidence here results in this 90-degree angle here, so what happens? This reflection here takes place, and this is the phenomena which is used here in the propagation of your light through your optical fibers here. So difference in density of two materials must be so that the beam of light which is moving through the core is refracted instead of refracted. That means it should reflect back here instead of getting refracted. So that means it will be moving like this. So that means we will have here on and off flashes. Sender will be sending the information, and through core and cladding, this is how it will take place here. Because it is getting here reflected, because we have two different materials having different density here. So optical fiber is used mostly in your backbone or backhaul networks because these can carry your transmission, your voice or data with very higher rates. And moreover, these fiber optics have higher bandwidth, so increased data rates. So signal can run for 50 kilometers without even requiring the repeaters. And moreover, the other advantages of these optical fiber here is that they are immune to interference. They have resistance to corrosive materials, which is less there in your coaxial cable or your twisted pair of cables. These have less signal attenuation. So the only disadvantage this media can come here is with like the cost, installation and maintenance, and fragility, because the material like your glass is plastic is very much fragile in nature here. So these are the technologies for your, or we can say that this is the wired transmission media. It means we're using a material like your physical conduit material, which will provide signal to be transmitted within its limit. That's we have wired media like your coaxial cable and twisted pair. So the signal will be traveling within the physical limits of these mediums here. So like your coaxial cable used in your like TV or in Ethernet, and your twisted pair are used as your local loops for your telephone systems, and these are here used for your fast transmissions and like your backbone or backhaul large networks. Now after the guided media, the another which transmission media which we have is your unguided media. We have the second one as unguided media. So unguided media, it means this is your wireless communication. You're not using any wired media. So wireless communication transports your electromagnetic waves without using any physical conductor. So signals are transmitted over air, and any device which is capable of receiving them can receive them. So we basically for our wireless systems we have antennas which propagate our electromagnetic waves, and they're transmitted over the air interface, and any other device which have the receiving capabilities can receive that information, like our BTS equipped with our antennas can transmit the data. So similarly our mobile station, our handheld devices also have receiving antennas, so that means they're capable of receiving the information, so they can receive the information from that transmitting end here. So we have here a radio communication band which ranges from your like 3 kilohertz to 300 gigahertz. So in this band, you will have a different number of frequencies, like ranging from very low frequencies to low frequencies, then from low frequencies to medium frequencies, high frequencies, then very high frequencies, ultra high frequencies, super high frequencies. So these will have different range. Like this will have from 3 kilohertz to 30 kilohertz. Then this have from 30 kilohertz to 300 kilohertz. Then this ranges to 3 megahertz and then 30 megahertz and so on up to your 300 gigahertz. Now these radio waves have different kind of propagations. Like means from I have here 3 to 300 kilohertz, so they will like go for surface propagation. Then some of the waves will be for your tropospheric propagation, ionospheric, and then from your like space line of sight propagation. So what we're using here is your radio waves, radio frequency waves here. So radio wave transmission utilizes 5 different type of propagations. For our wireless communication, we're using here these radio frequency waves. So these have different propagation modes here. Surface propagation, tropospheric propagation, ionospheric propagation, line of sight propagation. So that means they here have range up to 30 megahertz here. So if I talk here about your surface propagation, so these radio waves travel through the lowest portion of the atmosphere. That means they follow the curvature of Earth. These surface propagation or the ground waves, they follow the curvature of the Earth. After that, I have tropospheric propagation. So about tropospheric propagations, either the signal is directed in your line of sight, that means antenna to antenna, or they are broadcasted at an angle into the upper layer of troposphere, from where they get reflected back to Earth's surface. Now, after that, we have the ionospheric propagation here. So here the signals are radiated upwards towards the ionosphere, where they are reflected back to the Earth. So now, in ionospheric propagation, they are reflected back here because of the difference of the density between the two layers, because this layer has number of ions, so the waves are collided there. So there occurs a difference in the density of the ion and these waves, so they are reflected here back towards the Earth. And for this line of sight propagation, we require antenna to antenna. That means these two antennas should be highly mounted and they should be in sight of each other. So these are the unguided media, that means the electromagnetic waves which are not transmitted here using any physical conduit. That means they are not here contained in the physical limits of any particular device here. So after like radio waves, we have terrestrial microwaves also. So these terrestrial microwaves do not follow the curvature of Earth. Now, they requires line of sight for transmission and reception. So the distance here covered by the line of sight signal depends upon the to the extent to the height of antenna. Taller the antenna, longer the sight distance here. So that means height allows the signals to travel farther without being stopped by the curvature of the planet. So line of sight, that means they're not following the curvature of the Earth's atmosphere here. Now, we have satellite communication also. Satellite communication, that means we require a sending station at Earth, then the information will be forwarded to satellite and then reflected back to the another receiving Earth station here. So we have basically geosynchronous satellites which are orbiting the Earth here. So that means we have to maintain this line of sight condition here for your satellite operations also. Now, we have the main concern now here for in telecommunication, the cellular telephony. They are also using the wireless media here. So that means it provides here a stable communication between two stationary devices and two moving devices also. That means service provider has to locate the user, track the user, and then assign a channel and then transfer the signal as the user is moving here. So all of this here is done with your air interface. That means with the wireless medium here. We have different number of mobile station here. This is your air interface. All this is your wireless communication here. So this wireless media for cellular telecommunication is also using here these radio frequencies wave as a transmission media. That means wireless transmission media to convey the information. So now we are transmitting the information whether are using your wired media or your wireless media. We have certain kind of transmission impairments here. That means any transmission media is not perfect. There will be some imperfections in that media. That means there will be some loss of the energy, there could be the distortion of the energy, and certain kind of noises are also here there in the transmission media. So we have three different kind of transmission impairments here, and they are basically your attenuation, distortion, and noise. Attenuation, distortion, and noise. So attenuation basically refers to the loss of energy. So when a signal travels, it loses some of its energy to overcome the resistance of the medium. For example, we have wire carrying the electrical signal, so it gets sometimes warm. So that means due to the heat of that electrical component. So some of the energy of the signal is lost, so it has to compensate also. So this compensation here is done with the help of the amplifier. So that means if you're sending the information from this point to this point, there will be a loss of energy. So we're using here amplifier so that that loss could be compensated here to amplify the signal. Now after that we have distortion. So distortion basically means that the shape of the signal is changed. The signal is distorted. If your signal is a composite signal made up of two or three different signals, so each of the signal will have different frequencies and delays. So that could lead here to the distortion of the signal also. That means like we have multi-path propagation here in our wireless systems. After that, the third impairment which we have in our transmission system is the noise. So we have different kind of noise like thermal noise. So thermal noise is basically the random motion of the electrons in the wire, which are not usually transmitted by the transmitter, but they are induced here by the random motion. After that, we have induced noise, so which is basically caused by other appliances in the vicinity of our transmission media. After that, we have crosstalk. So crosstalk is the effect of one wire on the another. Because if one wire is acting as a sending, so other can act as a receiving antenna, and they can interfere with each other. So these are the various transmission impairments of your transmission systems. It means we have different impairments in your wired system also and in your wireless system. So this was just an introduction to the various transmission medias, wired and wireless. We will be studying more about transmission system in our next classes. So this is all for today. Thank you so much.